Hi everybody. So this is I'm trying to make a tutorial video for you people. So what I have taught in class today. So yes, we are starting with the first topic of igneous petrology. I'll do the introduction today in this video. So I've started with what is igneous petrology. So igneous petrology is basically the study of the magma and the rocks that crystallize from that magma. Okay, so let me start the laser pointer. Okay, so it's the study of the magma and the rocks that crystallize from that magma. Now the question is, what is a magma? So I have defined it, magma is defined as the hot fluid or the semi-fluid material from which igneous rocks are formed on cooling. In other words, it is actually the molten rock. Now it's basically a mixture. It can be a mixture of the melt and the crystals that crystallize from it and are suspended from it. So as long as everything, all the liquid has not crystallized to complete solid, anything in between from complete liquid to a mixture of liquid and solid is called a magma. Now the study of igneous petrology encompasses these broad aspects. Number one is the magma generation by melting and the subsequent rise of the magma. We know that or we will study that the magma has to be produced. It is not stored in some part of the earth. So if it has to be generated, then something has to melt to generate the magma. Okay, and it subsequently rises from the region from where it is produced. And then the evolution and the crystallization of the magma, how this magma which has formed evolves by crystallizing, and what finally crystallizes out of the magma. What are the factors which determine how the evolution will take place, what will crystallize. And finally the eruption and the emplacement of the magma. So the magma, if it comes out to the surface and erupts, then it's the eruption of the magma, or you know that it can be emplaced at the depth. So this is the emplacement of the magma. So these are the three topics which we will actually encompass in this course. So when a rock considered igneous, of course, when any rock which crystallizes from the magma is considered as an igneous rock. So the next part is how do we know that it is an igneous rock? Means the observational criteria to determine whether the rock is igneous or not. What are the other rocks which are there? It's metamorphic and sedimentary rocks, as well as there's the igneous rocks. So we need to know how we can identify igneous rocks. In the field, what we can do, mode of occurrence in the field, if it is an intrusive structure which is cross-cutting the country rocks, then it's definitely an igneous rock. For example, in the figure out here, this white rock is the country rock, whatever it might be, and you see this dark colored rock has clearly intruded into it. Then this black rock or this dark rock is definitely an igneous rock. Okay, we can have chilled margin in the intrusive structure. What is the margin of this intrusive structure out here? Along the pointer can be chilled, means very quick chilling, and it can form glass in sometimes. So if these are the features, then this intrusive body is definitely igneous. And there can be also localized baking of the country rocks. So these country rocks along the sides of these intrusions can be locally baked, and these are also signatures that this rock, intrusive rock, is also an igneous rock. And finally, volcanic structures. If you see a huge volcano, a shield volcano or a stratovolcano, or the different types of volcano, or a sill or a dike and a batholith, so these are all igneous rocks. The next thing is the textural criteria. Now if you have a hand specimen or you have a rock under the thin section, then how do we know? Okay, so the first thing is interlocking texture. You can see it in this picture, that all these needles of plagioclase are all haphazardly oriented, and they are interlocked with these dark and these brightly colored pyroxene minerals, and this type of texture is actually called an interlocking texture. If we see such a pattern, such an interlocking texture, it is only possible in an igneous rock, not in a metamorphic rock, and definitely not in a sedimentary rock. And the third thing is nearly perfect, or the second thing is nearly perfect crystal forms. For example, you can see a mineral out here, very nice crystal form, very straight grain boundaries, and this shape of the crystal is also preserved. So these are can be formed. These are very common in igneous because when a mineral crystallizes in a magma, it has open space to form nice crystal faces, which does not happen in a metamorphic rock, and sedimentary rock has a completely different way of forming. And finally, no foliations or primary sedimentary structures. Except the pyroclastic deposits in igneous rock, most of the igneous rocks or all of the igneous rocks do not show any foliation, okay, and they do not show any primary sedimentary structures. So if you have a metamorphic rock, most of the metamorphic rocks except a few will show foliation, and if you have a sedimentary rock, many of them will show primary sedimentary structures. So a combination of all these field and the textual criteria will guide you to recognize igneous rocks. So these are the questions. I won't go into the detail. You can read it. So these are the questions which will be addressed in this course. How are melts generated? What is melted and where? So what exactly, which rock or which part of the crust or the earth is melted, and where it is located? Is it the crust? Is it the mantle? Then what is produced by this melting, means what is the composition or the physical and the chemical properties of this melt which is produced? What controls this melting? And then why and how do melts crystallize to form igneous rocks? How do they crystallize? When do they crystallize? What are the controlling factors to form igneous rocks? What are the processes which accompany this crystallization? Why and how large varieties of igneous rocks are formed? We know there are a large variety of igneous rocks which are present on the earth. So how is this variety generated? What controls their formation? And finally, whether there is a relationship between the igneous rock type and the tectonic setting. If so, what controls this? So these are the required background knowledge. I won't get into it. I have explained in the class. Next, what we need to know or need to understand, revise again, is the structure of the earth. I have done this in the class, but you already know that we have the earth can be divided into the crust, the mantle, the outer core, which is liquid, and the solid inner core. This is based on the composition. There is a distinct composition difference between the crust, mantle, outer core, and inner core, where within the mantle you can have an upper mantle and a lower mantle with a transition zone in between. On the rheological point of view, it can be divided into the lithosphere, which is the outer rigid part of the earth, then the asthenosphere, mesosphere, and then the outer core, which is liquid, and the inner core, which is solid. How do we know that the outer core is solid? We have the S waves, which are actually transverse waves and which do not pass through a liquid. That's why we have actually, from that we come to know that the outer core is liquid. So the most important thing out here is to understand that the crust as well as the mantle is completely solid. So there is no place on the earth where magma is stored and which it comes out automatically. Yeah, here we have another term which we need to know is the geothermal gradient, which actually means is the rate of increase of temperature with respect to the increase of the depth, which is equivalent or can be related to the increase in the pressure in the Earth's interior. Okay, so what we see out here is temperature on the x-axis, pressure on the y-axis, which is basically inverted to give us an idea or a feeling that we are moving below the surface of the Earth from 0 to 10, and we have also the corresponding depth, which is given out here. Okay, so we have two colors. One is this shield of the continental geotherm in pink, and the blue, the oceanic geotherm. Okay, so we see that the geothermal gradient for the oceanic geothermal gradient is slightly different from the continental geothermal gradient. The temperature rises much faster compared to pressure, So the slope is much shallower in oceanic geotherm, while it is relatively much steeper in a continental geotherm. Okay, so here are the books which I'll be referring to, and I've said this several times in the class. These books are also mentioned in VLearn and in the Google Classroom, so you can look at these books. What I'll be mostly following is number 1, and there are different sections from 2, 3, and 4, which I'll be telling for each section. Next comes is the classification of igneous rocks. Now we have a large variety of igneous rocks which needs to be classified to have a proper nomenclature, and which has to be organized, and therefore there are preferred methods, or there are several methods in which one can classify the igneous rock. The preferred method for classifying any igneous rock, is actually based on the texture and the composition. What do we mean by the texture? Texture includes the grain size, the grain shape, the relationship between the grains. All these comes under the texture. And the number 2, composition, is based on the bulk composition of the rock and the mineral proportions of the rock. These are the 2 which comes under composition. So based on the texture, let's see how we do. So there are 4 divisions based on the texture. The first one is phaneritic, where the constituent minerals are readily visible by a naked eye, which means that the grain sizes of each of these minerals are more than 0.1 millimeter. Typically crystallized beneath the earth, which are plutonic or intrusive. So we'll come to this later, the relationship between the depth of crystallization and the grain size. But the most important for the classification is that if we can see the rocks with the naked eye, which is grain size greater than 0.1 millimeter, then it is phaneritic. Aphanitic is just opposite, where we cannot see the grains with the naked eye, which are less than 0.1 millimeter, are all aphanitic rocks. And then comes the porphyritic, where there is more than one mode of distribution, minimum bimodal distribution, or sometimes there can be trimodal distribution as well, which means that all the grains are not of the similar size. Some grains might be very big, some grains might be very small. So it's a 2-mode distribution, bimodal distribution of grain size. And lastly, glassy. Glass is basically where no crystal forms, or there is no time for the crystals to form from a magma. If the magma is chilled very fast, then there are no crystal forms and it forms a glass, which is isotropic. So if a magma chills to form a glass, then it is called a glassy texture. Now within that phaneritic, there are also divisions. It can be divided into fine-grained, medium-grained, coarse-grained, and very coarse-grained. So all are parts of the phaneritic. If it is fine-grained, it's less than 1 millimeter. So it's basically less than 1 millimeter and greater than 0.1 millimeter. So it's less than sugar granules. Okay, so it's smaller than sugar granules. These are fine-grained. Medium-grained is 1 to 5 millimeter, which is roughly in the range of sugar to a pea size, to a size of a small pea. And then the coarse-grained, which are 5 to 50 millimeter, which is 0.5 centimeter to 5 centimeter in diameter. And these are very coarse-grained, which are greater than 50 millimeter or greater than 5 centimeter in diameter, each of the grains of the rock.